All right, so we're going to take a look at a more complicated example when you're sketching the inverse relation of a given function. So I'm given a function on the right-hand side here, y is equal to f of x, and I want to sketch its inverse. And not only do I want to do that, but I want to state whether or not the inverse relation is a function or not. Okay, so just do what we did in the last example. The first thing you want to do is label some points here. So I have a point at -2, 4. All right, so because it is a more complicated graph, you're actually going to, sometimes it might help to label each and every one of the points you choose to take the inverse of. So I'm going to label that point as A. The next point I'm going to take the inverse of is 0, -6, which is the y-intercept right there. And I'm going to denote it as letter B. Okay, next point I'm going to choose is 2, 4. Okay, and I'm going to denote it as C. And finally, I'm going to pick a fourth point right at 4, 1, okay, which I will denote obviously as letter D. And the reason why I want to label them as A, B, C, and D is to actually keep track of the sequence at which these points are being connected. So obviously we're going in alphabetical order, A, B, C, and D, and you're going to keep that in mind when you take the inverse of each of your points. Because after a while, your points do get a little bit more cluttered, and you kind of lose track of what's going on. So sometimes labeling the points will actually make things a lot simpler. But make sure you memorize or you keep in mind the sequence at which these points are connected. So like I said, I'm going with A, B, C, and D. Okay, so we want to take the inverse of each of these points, and it's quite simple. All you have to do is switch around your x and y values. So this point's going to be 4, -2. All right, this point's going to become -6, 0. Okay, and this is 4, +2, and this is going to become 1, 4. All right, so we're actually going to call these different points. Remember, this was A, so I'm going to call this point A prime. Okay, so a little tick at the very top there. Remember, this was B, so I'm going to call it B prime. Okay, this was C, therefore this is C prime, and obviously this is going to become D prime. All right, so let's go ahead and plot these points and connect them in the A, B, C, D order that we have here. So 4, -2 is going to be right here, okay, and -6, 0, which is right there. Oh, sorry, I should be actually labeling these. So A, B prime. And actually, I'm going to get rid of the old labels here. So that way we could just keep track of one graph, okay? So A, B prime, and we have 4, 2 for the C prime. And finally, we have 1, 4 for the D prime. Okay, and this is why it becomes really simple in the end once you label those points. Now you know you must go in the sequence A, B, C, and D. So let's go ahead and try to sketch this graph. And I'm going to try my best here drawing straight lines. And it's going to look like this. A to B, B to C, and C to D. Okay, so obviously mine's not as perfect as it should be, but there's your inverse graph right there. Okay, so you know it's the inverse graph because you know it's the reflection in the line y is equal to x, which I have already preloaded here. So as you can tell, each point has been reflected in that line. So last thing we want to do is state whether or not this inverse graph is a function. And remember, to determine if a graph is a function or not, all you have to do is apply the vertical line test. So if I take a vertical line and I draw it, okay, does it pass through more than one point on the inverse graph? Well, actually it does. It crosses right there, and it also crosses at a second point. So that means this inverse relation graph is not a function. So the inverse is not, okay, not a function because it does not pass that vertical line test. Okay, so that is it for my more complicated example and how to sketch the inverse of a given function.